Hello everyone, my name is Saili Kadam. In this video, we will be talking about types of boosting techniques. So in our previous videos, we discussed what are the ensemble techniques, why do we use them. Then two types of ensemble techniques we have already discussed, that is bagging and boosting. So further, boosting has three different types. So generally we know what exactly is boosting technique. So basically boosting is when we sequentially train the models, that is boosting one after the other. So the result of the current model depends on the errors or result of the previous model, that is the boosting. So we have multiple boosting techniques, so let us study them in detail today. So the first type of boosting technique, we already know there are basically three types of boosting techniques: AdaBoost, XGBoost, and gradient boosting. So these are three types of boosting techniques. So firstly, we have AdaBoost. So AdaBoost is a simple, the way it works is a bit simple. So basically, as it is a boosting technique, that means the performance of the current model depends on the performance of the previous model, that is boosting. So here what specifically changes is that the results or the uh, errors made by the previous model, they are given more importance in case of AdaBoost. So we have multiple models. This primary focus on the second model or the next, the consecutive model will focus more on the uh, errors. So it will give more weightage or it will give more importance to the incorrectly classified data point. That means the errors made by the previous model, they are given high importance or high weight, or the primary focus is on this. So let us consider an example. Let us say we have five different subjects and you know which is the subject that you are weak in. So when it is the exam time or when you are preparing, when you are studying, you prepare more of the subject that you are not good in. Or let us say I am weak in maths, so I will give more attention, I will give more importance, I will study more for maths. Exact working is for AdaBoost. The errors made by the previous iteration or made by the previous model, they are considered or high importance is given to those errors. So this is how AdaBoost works. So these are the working steps of AdaBoost, that when we start, every single point, it has some equal weight. So we start with the equal weight, then we first train first decision tree. So usually we consider decision tree or basically random forest. So random forest is actually a bagging technique. But just for an example, let us say we have different decision trees. So we train first decision tree, then we identify what are the misclassified samples, that are the errors, then we increase their weight. So at the beginning we start with equal weights, we give equal importance to all of them. Whereas when we identify what exactly are the errors, then what do? We increase their weights, we increase the weights of the misclassified samples or the errors. Then next tree will repeat with the updated weight. So now first tree will have everything equal, then second tree won't have the weight, equal weights. Whatsoever was misclassified, that weight will be increased, and for others the weight will remain the same. And then we repeat the process of training, and at the last we combine as usual. For classification, we generally perform voting. So let us say that when my semester begins, at that time I decide that I will study 1 hour for every single subject. That means equally, equal weightage is given to all of them. So after a test or something, I understood that I am not weak, I am not good in some two subjects. So what will I do? I will increase their timing to 1.5 hours or 2 hours. So this is how we first give equal weightage to all the data points. When an error occurs or something like that happens, then we simply increase their weights. Then we have advantages of AdaBoost. So it is very simple. The implementation or the understanding is very simple. Then the training is fast and good accuracy on clean data set. So when the data set is clean, what does this mean? That means that when we have there are outliers are not present in the data set or something like that, and the data set is clean. In those cases, AdaBoost works well. So this is about AdaBoost. It has some disadvantages also, that when we have outliers, so noisy data, or when we have outliers present in the data set at that time, it is very sensitive. That means result can vary a lot if outliers are present in the data set and can overfit the noisy data set. So when we have noisy data sets, in those cases what will happen, it can overfit them. So this is AdaBoost, very simple boosting technique. Then we have gradient boosting. So gradient boosting is basically what it does. It tries to. So as we said that in AdaBoost we focus more on the misclassified points or the errors. We increase their weights, whereas what does gradient boosting do? Each model predicts the errors made by the previous model. It don't change any weight. It tries to minimize the error. So in AdaBoost, we increase the weight of the misclassified points, we give them more importance, and then we perform the same process. Whereas whatsoever is correctly classified, here we don't focus on that much. What we do is we give, or we try to minimize the error by uh, like grade descent. This is basically it's nothing but finding the derivative at every step so that we reduce it. We will be discussing gradient descent in detail in some other video, but basically it involves the concept of derivatives so that we could decrease it. So basically the difference in between AdaBoost and gradient boosting is, here we simply, in AdaBoost we increase the weights. Here we don't have anything to do with the weights. We simply take the errors and we simply try to minimize the errors. We don't increase, we don't reduce their weights. That is the difference in between AdaBoost and gradient boosting. Then it also has some working steps. So basically it will obviously start with one tree. We will calculate the errors, prediction errors. Then we train a different tree on those errors, and we keep on adding different trees so that we could improve the prediction, or we could improve the accuracy. And we repeat the same process till the time we don't find or the error gets minimized. A very small error is remaining, till that time we will repeat the same process. But the important concept behind gradient boosting is that it uses gradient descent. Gradient descent is a method where we use the concept of derivatives to minimize a loss function, or minimize like in this case we can say we minimize the error. Gradient descent itself is a quite big concept, so we will be talking about that in some other video. So again, this has some advantages. It has higher accuracy as compared to the AdaBoost. The main difference in between AdaBoost is AdaBoost increases the weight of misclassified points, whereas in gradient descent we don't increase it. We focus on the errors and we try to minimize the errors by a gradient descent method. Then it can work for both classification as well as regression, and it handles patterns well. So if there are few patterns in our data set, we should go for gradient boosting. Then again it is, so AdaBoost is comparatively fast, we discussed just a few minutes ago. So gradient boosting is uh, quite slower. Then it can also overfit when there are too many trees when we use. So basically AdaBoost can also overfit, and even the gradient boosting can also it can also cause overfitting. Then we have parameter tuning is required in this case. So then we have extreme gradient boosting. We call it as XGBoost as well. So it is nothing but an advanced version of gradient boosting. So whatsoever is present in gradient boosting, that will continue here as well, but it has some additions, or it is optimized implementation of gradient boosting. Basically the working or the concept behind gradient boosting and XGBoost is similar. It is an developed, or it is an advanced version of XGBoost where we can gradient boosting, where we can say that it is better in terms of speed, accuracy and stability when compared to gradient boosting. But very important thing, it is optimized version or optimized implementation of gradient boosting. So it will have whatever is present in gradient boosting, it continues in XGBoost as well, but the implementation changes and there are few additions which XGBoost has its on its own, but the concept remains the same, that use gradient descent to minimize the errors. So what are the additional features? So regularization. Regularization is, again, we try to minimize the loss function here. So regularization itself is a very big concept. It has two types, lasso regression and ridge regression. It, as I said, itself it is a very vast topic, so we will be talking about it in a different video. So we can have our upcoming videos on descent, gradient descent and regularization. So regularization itself is a very vast topic. In this video we will be just introducing, or regularization is a technique where we try to reduce the errors or a loss function, that is regularization. There are two types of regularization techniques, lasso and ridge regression. Then we say that parallelly process. So boosting is simply very important thing, or very important difference in between gradient boosting and XGBoost. In gradient boosting we train the model sequentially, whereas in XGBoost we parallelly perform the processes. It can handle the missing values. Then so we have discussed tree pruning in decision tree video, when we discuss that pre pruning and post pruning. So we try to avoid overfitting, so that we, whenever the size of the tree or the nodes or the depth of the tree increases, decision tree can cause a overfitting. So to reduce that, we use the concept of tree pruning, and tree pruning is basically we have discussed it in a very much detail in decision tree. So if you want to go through that concept, please go through that video. Then we have faster computation. So it has the things, or the implementation or the working remains the same. There are very few differences in between XGBoost and gradient boosting, but some extra features are added to XGBoost. So this is XGBoost. Then again it has its own advantages and disadvantages. So the first advantage is that it gives you high accuracy, uh, fast training, it can handle missing values. Again, it prevents overfitting. So it has an additional feature, that is tree pruning. So because of that we can easily overcome, or we can prevent overfitting. And so it is used, so applications are wide, very huge applications XGBoost has, because it has many advantages. So AdaBoost improves accuracy, but gradient boosting gives us better accuracy, and the best accuracy is given by XGBoost. So again, as we discussed before as well, that is gradient boosting, it is fast in training. In the similar way, even XGBoost we can train in quickly, we can train it. Then again, it has disadvantages, because some of them are same as before, that is gradient boosting. So we need parameter tuning in this case as well. In our upcoming videos we will be talking about many concepts, then slightly harder to understand. It is because it has some implementations, advanced implementations, and the parameter tuning comes in picture. So this makes us quietly, people usually don't understand XGBoost, but yeah, the concept is similar, but implementation gets difficult and it requires more computational resources. So this was different techniques of boosting, and in our upcoming videos we will be talking about gradient descent and many more different concept that we involve, or we also have some terms as accuracy and recall. So there are a lot of things that we will be covering in our upcoming videos. So that was all for this video, and thank you.